Hello, hi everyone. Welcome to the Student the Brand. Hello, students. Welcome to the Student the Brand. So today we are going to discuss about motion in a plane. Motion in a plane. So let's start discuss about it. Motion in a plane. So here, when you throw the object moves on the ground. Then if you are describing the position of the object, okay, so with the help of one coordinate axis, then we can say the object is in one dimensional motion. So when the body is okay, when you throw the object, yes or no? So if you want to describe the motion of an object, if it is required two coordinate axis, then we can say the body is moving two-dimensional motion. That is nothing but motion in a plane. So example for motion in a plane, we can say so which one we can say example? Example is the body is moving a circular motion. The body is moving a circular motion, that we can say example for motion in a plane. Motion in a plane, right? So that is example for motion in a plane. And a body is projected. Okay, so that is considered as a motion in a plane. So projectile motion. So the body projected up on the plane, so down the plane, okay, in the air, like that. So we can say, we can take so many examples. So in this class we'll discuss about okay, vectors and scalars along with that motion in a plane. That only. So topics related to that only we are discussing. So now first of all, so we'll discuss about first point is scalar. Second one is vector. So what is scalar? Scalar is nothing but a physical quantity which has only magnitude. The physical quantity which has only magnitude, that is called scalar physical quantity. Simply we can say scalar quantity. Example for scalar quantity. What is the example for scalar quantity? Example for scalar physical quantity: distance, mass, density, speed. These are example for scalar physical quantity. Coming to vector physical quantity, the quantity which has both magnitude and direction. The physical quantity which has both magnitude and direction. Okay. So that we can say vector physical quantity. Example displacement, velocity, acceleration, linear momentum, force. These are vector physical quantities, right? Yes. Now, types of vectors. So here we go. We have to discuss about types of vectors. 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 So first one is equal vectors. Equal vectors. Equal vectors. Second one is negative vectors. Negative vectors. And coming to third one is zero vector or null vector. Zero or null vector. Zero or null vector. And fourth one is unit vector. Unit vector. And coming to, so these four we'll discuss. So later we have to discuss orthogonal unit vectors, collinear vectors, coplanar vectors, all those things we'll discuss. So coming to equal vectors. Equal vectors. So the vectors whose magnitude. So two vectors having equal in magnitude at the same time acting in the same direction. So both are having equal magnitude at the same time they are acting in the same direction. Okay. So these vectors are called equal vectors. Coming to negative vectors. Vectors are having equal in magnitude but they are acting opposite in direction. Opposite in direction like this. So they have equal magnitude but direction wise acting in opposite to each other. Okay, opposite each other. So coming to null zero vector, null vector. The vector whose magnitude is zero. Magnitude is zero, that is called zero vector or null vector. Coming to unit vector. So A cap equal to A bar by mod A bar. The vector whose magnitude is 1 unit. The vector whose magnitude is 1 unit, that is called unit vector. The vector whose magnitude is 1 unit, that is called unit vector. Understood or not? Understood or not? This is about equal vectors. Okay, equal vectors. Equal vectors, negative vectors, zero vectors, and unit vectors. Is it clear? Right? Yes. So here I'll give an example for unit vector. So I'm taking A bar equal to Ax I cap plus Ay j cap plus Az k cap. So if you are taking mod A bar equal to root over Ax square plus Ay square plus Az square. So A bar mod A bar equal to x square plus Ay square plus Az square. Suppose you are taking A bar equal to 2i cap 3j cap plus 4k cap Then you'll get mod A bar equal to root over 2 square plus 3 square plus 4 square. Then root over 4 plus 9 plus 16. Then you'll get root over 29. So mod A bar equal to root over 29. Okay. So how can we write A cap equal to A bar is how much? A bar is this one. So here A bar, that is 2I cap plus 2j 3j cap plus 4k cap by, so root over 29. So like this we can find out. So magnitude means we have to find out like this. So this is the magnitude of the vector. Understood or not? So I hope it is very clear. This is about unit vector. Next one, orthogonal unit vectors. Orthogonal unit vectors. Fifth one. Orthogonal unit vectors. Orthogonal unit vector, fifth one. Those are I cap, j cap and k cap. So here you can see I cap, j cap and k cap. So along x axis, along y axis and z axis. So I cap, j cap, k cap are the unit vectors acting along x axis, y axis and z axis. So these vectors are perpendicular to each other. These are called orthogonal unit vectors. Orthogonal unit vectors. Understood or not? So now, sixth one, co-initial vectors. Co-initial vectors. Co-initial vectors. So vectors having initial points same. So vectors having same initial point. So I am taking A bar and B bar. So the angle between two vectors is theta. Co-initial vectors, right? 6. Next one, collinear vectors. Seventh one. So collinear vectors. Collinear vectors. So vectors are acting in the same direction and the same line, A bar and B bar. And eighth one, coplanar vectors. Coplanar vectors. Okay. Coplanar vectors means if you are taking x-axis, x, y, so here you can observe z. So vectors are acting in the same plane. Okay, so irrespective of direction and magnitude, vectors are acting in the same plane. Okay, so these are called coplanar vectors. Coplanar vectors like this. So next one, localized vector. Localized vector. Ninth one. Ninth one, localized vector. Localized vector. And so 10th one is non-localized vector. Non-localized vector. Okay, localized vector, non-localized vector. So coming to localized vector, the vector whose initial point is fixed. The vector whose initial point is fixed is called localized vector. The vector whose initial point is not fixed, that is called non-localized vector. The vector whose initial point is fixed, that is called localized vector. The vector whose initial point is not fixed, that is called non-localized vector. Non-localized vector. And next one, position vector. Position vector. So 11th one is position vector. Position vector. Position vector. So here I am taking x-axis and y-axis. X-axis, y-axis. So this is the vector. So this is the vector A bar. So you are representing this the position R bar. Okay. So with respect to coordinate axis, from the origin, we are representing this vector. So there is a position vector. Coming to displacement vector. Displacement vector. Displacement vector. Okay. So here you can observe I am taking so x-axis, y-axis, and here I am taking this is A bar, and this is B bar. So R1 bar, this is R2 bar. This is the displacement vector. There is nothing but R2 bar minus R1 bar. Okay. R2 bar minus R1 bar. That is the displacement vector. Understood with respect to coordinate axis. So we are representing the vector. So that's why it is called a displacement vector. Localized vector, non-localized vector, position vector, displacement vector. Okay. So next one. So I'll discuss about one more. That is so addition of vectors. So types of vectors completed. Now we'll discuss about addition of vectors. Addition of vectors. Okay. Addition of vector. There are three types of vector addition. Point number 1. Triangle of vector addition. Triangle of vector addition. Triangle of vector addition. Okay. Triangle of vector addition. Next one, polygon law of vector addition. Sorry, parallelogram of vector addition. Parallelogram law. And the third one is polygon law of vector addition. Polygon law of vector addition. Triangle law of vector addition. Parallelogram of vector addition. And coming to the next one, polygon law of vector addition. So these three we are discussing now. Okay. Triangle law, parallelogram law, and polygon law. Okay. So next we'll discuss about triangle of vector addition. We'll discuss briefly. Triangle of vector addition. Okay. So triangle of vector addition. Triangle of vector, triangle law. So triangle of vector addition, if you take, okay, so two vectors are acting along the two sides of the triangle. So A bar is acting like this and B bar is acting like this, and the resultant is acting Opposite of these two vectors, that is C bar. Okay, so C bar equal to A bar plus B bar. Okay, A bar plus B bar. Understood or not? So A bar and B bar acting in the same direction. Then C bar is acting opposite to each other. Right? Opposite of remaining two vectors. Opposite of remaining two vectors. Understood or not? Okay. So next one. Next one. So we'll discuss one more. So you can see here. I'm taking here like this. So this is one vector and this is one more vector. So here you can observe A bar and B bar acting in one direction. So A bar and B bar are acting one direction, C bar is acting opposite. So C bar equal to A bar plus B bar. So here A bar and B bar acting in one direction, C bar is acting opposite. So C bar equal to A bar plus B bar. So like this we can take. Now parallelogram of vectors. Parallelogram of vectors. Parallelogram of vectors. Parallelogram of vector addition. Parallelogram of vector addition. Parallelogram of vector addition. So two vectors are acting along the two sides of the parallelogram. So the angle is theta. A bar is acting here and B bar also. So A bar is acting along this direction and B bar is acting along this direction. The angle between these two vectors is theta. Okay, so now the resultant is acting exactly center here like this. This is a resultant. So we can take angle here. So here you can observe. This is a theta. Now, so I am drawing A bar along this one and B bar. So this is A bar and this one is B bar. Okay, this is a resultant R bar. Then you are extending here. This is extension. Theta x y. Okay. So now you can observe. Somewhat you can take. So actually here it should come like this. Okay. I hope this is sufficient. Okay, done. So here B bar and theta. This is theta and B bar x, y. Now you can take, this is a right angle triangle I am taking. This is a right angle triangle. So B theta x y. Cos theta formula is adjacent side by hypotenuse. X equal to B cos theta. And sin theta formula is y by b, that is equal to y equal to b sin theta. Okay, so now if you want to find out the resultant r bar equal to, so r square equal to, resultant r square equal to a plus x whole square plus y square. So here a plus x equal to b cos theta, y equal to b sin theta. Substitute here. R square equal to a plus b cos theta whole square plus b sin theta whole square. Then we will get r square equal to a square plus b square cos square theta plus 2ab cos theta plus b square sin square theta. Okay, so we know that sin square theta plus cos square theta equal to 1. So here you can take in these two terms. So b square you are taking common. Then r square equal to a square plus b square plus 2ab cos theta. So then r equal to root over a square plus b square plus 2ab cos theta. So this is the formula. So r equal to a square plus b square plus 2ab cos theta. I hope it is very clear. Understood or not? Okay, so I hope it is very clear. So this is about parallelogram vector addition. Now we'll discuss about polygon law. Polygon law is same only. Polygon law is same only. So polygon law vectors. Polygon law is nothing but so vector a bar, b bar, c bar and d bar, e bar, and the f bar is acting along this direction. F bar, so f bar equal to a bar plus b bar plus c bar plus d bar plus e bar. Okay, so f bar equal to a bar plus b bar plus c bar plus d bar plus c bar. Understood? That is the resultant. That is a polygon law vector. So next one. So we'll discuss about one more. That is multiplication of vectors. So here you can observe, or just simply we can say product of vectors. So here there are two types of product of vectors. One is dot product or scalar product. Dot product or scalar product. Second one is cross product or vector product. Cross product or vector product. Understood or not? Dot product or scalar product, cross product or vector product. So why you are calling it is a dot product or scalar product, a cross product or vector product? Why? So because when you are getting the final result in a dot product is a scalar, there's only magnitude will get. In the final result of cross product is a vector. So product of vectors in that, so we'll discuss about dot product. Dot product if you are taking, okay, dot product or scalar product, dot product or scalar product. So the dot product of two vectors a bar dot b bar equal to ab cos theta. So the dot product of two vectors is equal to product of their magnitude and cosine angle between them. Suppose I am taking a bar equal to 2i cap plus 3j cap plus 4k cap and b bar equal to 4i cap 3j cap plus 2k cap. If you want to find out dot product of two vectors, 8 plus 9 plus 8, 16 plus 9, 25. So you will get, so you got a scalar, right? That is nothing but only magnitude you got, that is 25, right? Only value you got. So coming to the vector product or, okay, so now you can see scalar product. Scalar product completed. Next we'll discuss about vector product, that is nothing but vector product. That is nothing but cross product. Cross product. Cross product or vector product. So this is very, very important. So you can observe cross product or vector product. So now you can see the cross product of two vectors is equal to product of their magnitude and cosine angle between them. Sorry, sine angle between them. Sine angle between them. So now you can see a bar equal to 2i cap, 3j cap and 4k cap and b bar also. So 2i cap, j cap, 3k cap. So suppose I am taking like that. So now a bar cross b bar you have to find out. How to find out a bar? So I cap, j cap, k cap. So write 2, 3, 4, 2, 1, 3. So now you can say I cap. So you have to multiply, you have to take 2 by 2 matrix. So 9 minus 4 minus j cap 6 minus 8. So you have to remove this column. Okay. Now place k cap equal to k cap. So 2 minus 6. 2 minus 6. Understood? Once again, I cap 9, 4, j cap 6 minus 8 plus k cap 2 minus 6. Yes. So now you will get I cap 5i cap minus 2j cap plus minus 4k cap. So finally 5i cap plus 2j cap minus 4k cap. So you got a vector, right? So finally you got a vector. That's why it is a vector product or cross product. vector product or cross product. That's why, so we are calling it is a vector product or cross product. Understood or not? I hope it is very clear, right? Yes. Next one. So you got vector and scalar. So completed. Now we'll discuss about projectile motion. Projectile motion. Projectile motion. So if you are throwing a particle into the air, so if you are throwing a particle like this, so into the air, right? So along x-axis and y-axis, so you have to think. Here resolution of a vector is very, very important. So already discussed. Okay. So the same thing we will discuss once again. We'll discuss once again. Okay, so here you can see. So x-axis and y-axis and this the projectile motion. We have to prove the trajectory of a projectile is a parabola. The trajectory of a projectile is a parabola. Understood? Okay, so now you can observe. So initially the particle is thrown with the initial velocity and it making angle theta with x-axis. So at a certain point, so you can observe. Okay. Here at certain time, that is V. So I am taking V. After a certain time V. So Vy equal to, so we have to divide U velocity vector into two components. So I'll divide here, you can take x-axis and y-axis. This is the velocity vector along x-axis, y-axis, theta. So x, y. Now you can see cos theta equal to adjacent side by hypotenuse, adjacent side by hypotenuse we can take. Adjacent side is x, hypotenuse is u. X equal to u cos theta, and sin theta if you are taking y by u, that is y equal to u sin theta. So along x-axis you can take u cos theta, along y-axis you can take u sin theta. Okay, so that is ux and uy. So we can take along x-axis and y-axis. Along x-axis and y-axis, right? Along x-axis and y-axis. So along x-axis u cos theta, along y-axis u sin theta. Ux and uy. So after certain time Vx equal to u cos theta only, and Vy equal to u sin theta. So at this, but at the maximum height, you can observe, so only u cos theta will be remaining, V sin theta is Vy equal to 0. Vy equal to 0. Understood or not? So when it is reaching to the maximum, okay, when it is reaching to the maximum height, so body velocity becomes 0. Understood? So I hope it is very clear. So only horizontal component of velocity will be remaining. Only horizontal component of velocity u cos theta will be remaining. So now you can see, we know b square minus c square equal to 2s, and v equal to u plus at, s equal to ut plus half at square, kinematic equations. Those are v equal to u plus at, s equal to ut plus half at square. So v square minus u square equal to 2as. Okay, these are the equations of motion. Equations of motion. So we have to think along x-axis and y-axis. So that is nothing but horizontal components, horizontal direction. That is nothing but along x-axis, x-axis, and along y-axis. Along y-axis you have to take, that is vertical component, vertical direction. Along x-axis and along y-axis you have to take. Alright, so now you can observe these components along x-axis. So ux and vx, anyway vx becomes 0, then ax and s equal to x. So like that you can take vx equal to ux plus ax into t. T is same only. So what are the direction, what are the quanta? Okay. So system, so x equal to ux t plus half into ax t square. And coming to third equation, vx whole square minus ux square equal to 2axx. And coming to the vertical direction by equal to uy plus ay into t. So second one is y equal to uyt plus half into ayt square. Coming to third one, so vx whole square minus ux whole square equal to 2ax, oh sorry, y, right? So y you have to take, y you have to consider here, y. So uy, u, vy, uy, ay and y. Okay, so I hope it is very clear, understood? So like that along x-axis and along y-axis you have to consider. Along x-axis and along y-axis you have to think. Along x-axis and along y-axis. Understood? Now we can take s equal to ut plus half at square. S equal to ut plus half at square. So s equal to ut plus half at square. So along x-axis if you are taking, so x equal to ux t. So throughout the path, horizontal component of velocity is same, u cos theta. So automatically x becomes 0. Okay, then so place half into ax t square, then you can see x equal to u cos theta, horizontal component of velocity, into a0, then this term becomes 0, then t equal to x by u cos theta. So equation 1. Coming to the next one, here s equal to ut plus half at square. Coming to y-axis, y equal to uy t plus half into ay t square. So ay along y direction, so along y direction you have to take minus g. Ay equal to minus g, uy equal to u sin theta. Right? So now substitute y equal to u sin theta into t plus half gt square. So t value you know right here. What is the t value? X by u cos theta. Substitute the values. So y equal to u sin theta into x by u cos theta minus half into g into x by u cos theta whole square. Then y equal to here, you can take u get cancel. So tan theta x minus g x square by 2 u square cos square theta. So it is in the form of ax plus bx square. So equation of a or path of the projectile or trajectory of a projectile is a parabola. Trajectory of a projectile is a parabola or path of the projectile is a parabola. Okay. So like that we can take it. Understood or not? I hope it is very clear. Is it clear? That is about projectile motion. Okay. Now, so we'll discuss about time of flight, maximum height and horizontal range. Okay. Time of flight, maximum height and horizontal range. Time of flight. Time of flight. Time of flight. Okay. That is s equal to ut plus half at square. So in this case, s equal to y, uy equal to u sin theta, and so ay equal to minus g. So along vertical directions, if you think, so bodies went to the maximum height, okay, so and reach to the same. So ground along vertical direction, body is thrown from the ground, again reach to the ground. So then y equal to 0. Then u sin theta, so maximum, so time of flight, time taken by the body to reach the maximum height, g t square. Then of g t square equal to u sin theta into t, capital T. So here you can see, so tt get cancel, then t equal to 2u sin theta by g. Time of flight, time taken by the body to fly in air. Time taken by the body to fly in air is called time of flight. Okay. So t equal to 2u sin theta by g. 2u sin theta by g. So coming to the maximum height. Maximum height. Maximum height. Coming to maximum height. That is v square minus c square equal to 2a. So time of flight formula you can write t equal to 2u sin theta by g. Time of flight. T equal to 2 time of flight equal to 2u sin theta by g. 2u sin theta by g. So I have this habit writing continuous. Stop. T equal to 2u sin theta by g. Yes. Okay. So now maximum height. V square minus c square equal to 2as. Now you can see vertical height. So Vy square Uy square equal to 2 minus GH. So here 0, it reached to the maximum height. U sin theta whole square. Then minus 2GH minus U square sin square theta minus 2GH. Minus minus get cancel. H equal to u square sine square theta by g. 2g. What is that? 2g. Okay, so 2g. U square sine square theta by 2g. So very, very important. Understood or not? So next one, we'll discuss about horizontal range. Horizontal range. Horizontal range. Horizontal range. That is, so the body, so this is the point of projection A and it is a point of striking the ground. So S equal to ut plus of at square. Here you can observe x ux t plus of ax t square. So let it be t. Here horizontal. So along horizontal direction ax is 0, right? Because velocity component is same. So then, so time of flight formula I already wrote there. Now you can see horizontal distance, that is nothing but horizontal range. So we are denoting with x equal to r. That is r equal to u cos theta into, so this total terms become 0, x equal to 0. Then 2u sine theta by g. So now r equal to u into u square. So 2 sine theta cos theta by g. So then you will get r equal to u square sine 2 theta by g. Okay, so this is the formula. So I hope it is very clear. Understood or not? So if you like the content, if you like the channel, if you like my explanation, do like, share and subscribe to Student the Brand. So thank you so much for joining and attending and listening my class. This is your Siva sir signing off. Thank you.